Good morning to everyone. My name is Srivashni. I am from CSCC. So today's my topic is recursion method. So introduction to the recursion method. Recursion is a programming techniques where a method calls itself to solving problems. So to solve a problems in a technical way in programming is known as recursion. It is often used to solve problems that can be divided into smaller similar sub problems. So these are the problem solving often dividing uh, into two smaller. So understanding recursion is a uh, for solving complex problems efficiently in Java. So by the recursion, we can solve the problems in a easier method. So recursion in Java, consider the following methods to print a line of star star characters. So in this image, we can see how the program was there for recursion method. So public static void print stars. So we need to print stars int n is equals to stars. So int I in we need to write in for loop uh, for int I is equals to 0, I greater than n means how many we are taking, like stars, I plus I will be incremented. So again we need to take print statement. So system.out.print. So we need to print start. So uh, we need to text in double quotes in stars. uh, Here we are ended the for loops, and again we need to print empty, so it will give the output. So system.out.print ln. So parenthesis semicolon. So this is the end of the output. How recursion works. A recursion method consists of a basic class and a recursion class. So the basic class stops the recursion, preventing an infinite loops and allowing the methods to return a result. So by the basic case stops the recursion. So it will provides infinity loops to allow the methods and returns and results. So we need get result and returns, so that we need to use infinity loops. So it is helps in a basic case. The recursion case calls the method itself with the modified parameters to approach the basic cases. So we can see in this image, top of the stack, basic basic cases and recursion cases. The basic cases in is the simplest instant of the problems that can be solved directly. So basic case is a simpler instance to solve a problem directly. So it will directly solve the problem whatever it is. In the constructs, the recursion cases reduce the problem size, drawing it closer to the basic cases. uh, Properly defining these cases is efficient for avoiding stack overflow errors due to infinite recursions. So in this we can say that efficiency for avoiding stack overflow errors due to infinity recursions. So in this image we can see how the recursion functions are there. Int recursion x, so function becoming called again itself. So again we need to take if loop x is equals to 0. So returns semicolon. Again recursion x minus 1. So here x minus 1. So what we are given in x, that is minusing 1, so we can get the answer. Example, factorial calculation. The factorial calculation, the factorial of a non-negative integer n is the product of all positive integers up to n. The recursion definition is uh, factorial n, factorial into n is equals to n, factorial n minus 1 with factorial 0 is equals to 1 as the base case. So we can see in this image, find the factorial using recursion in recursion Java. So in input number is equals to 4, basic case is equals to if input number uh, greater than is equals to 0, returns 1, factorial 4. So in factorial 4 means so 4 cube will come, so it is 24. So first we should start with return 4. So factorial 4 into 3, so 4 into 3, again 4 into 4, 4 into 3 means 4 into 3 into 2 into 1. So for the 4 to at the end of the 1, we need to reverse method. So 4 into 3 into 2 into 1 is equals to 24, returns 3. Again factorial 2, 3 into 2 into 1 is equals to 6, returns 2, factorial 1, 2 into 1 is equals to 2, so return 1. So Java implementation of factorial. Basic case, if basic case, if n is equals to 0, so it returns 1. Recursion case returns n into factorial into n minus 1. So this program calculates the factorial of 5 and prints 120. So factorial of 5 means, so 5 into 4 into 2 into 1, so that is equals to 120. So you can see in this image how the function of a Java will be programmed. So public class factorial, public static int factorial int n. N is what we are taking number. So if n is equals to uh, 0, returns 1, semicolon, it is a basic case. Return n into factorial n minus 1, semicolon, it is a recursive case. So public static void mean string strings and strings arguments. Again we need to take up, we need to print the how many we are taking factorial. So here n should, n means we are taking the number, so we are taking as a 5. So system.out.print factorial 5, so output will become 120. So this is the program of Java implementation of factorial. uh, rec- uh, Visualing recursion can helps understanding how the methods call unfold. So visualing how we are visualing, like in program we are doing in process of method. So we are not without doing program, by taking one number in our mind, so it is imagine and now we are taking 5. So 5, how can we do in recursion method, in factorial method? So we are imagining that 5 into 4 into 3 into 2 into 1. So by that we are visualizing our recursion. So we can unfold that, we can use call method unfold. Each call to the method creates a new stack frames, and they are solved in a last in first out order. So this visualing recursion is a method that creates the stack frame. So how they start means in the last in and first out. So we can see in this image, first 0 was entered and another uh, 1 and 2 3 4. So it is the stack function. First will be last in and first out. So first entered 0, so it will be the first. So last entered means 4, so 4 will be out first, and like first in and first out. A recursion tree or diagram can illustrate the relationship between calls and how they combine to provide the final results. Advantages of recursion method can leads to simplified and more reliability code compared to um, iterative solution. So it will be lead to simplifier and more reliability code. This naturally fits problems that have a recursion structure. Such a tree travels and combinator problems. So recursion can reduce the amount of the code needed to implemented create algorithms, improves manageabilities. Disadvantages of recursions. One major withdraw of recursion is the risk of stack overflow if the recursion depth becomes too long. So by the taking uh, long method now now we are taking example 5, 0 to 4 in the stack method, last in and first out. So by taking that when we are taking larger value and larger number lines, this is tough to take out in visualization recursion. So it is disadvantages of recursion. uh, Recursion method may have higher time complexity than their irrelative uh, counterparts, leading to performance issues. Debugging recursion method can also be more challenging due to the multi layers of method calls. So trail recursion is a special case where the recursion calls is the last operation in the method. So in this recursion method, tail method is the last method. So some programming language optimize trail methods to reduce stack usage, but Java does not have this optimization. So in programming language optimization, uh, trail recursion to reduce stack usage, but in Java it does not optimization. So writing tail recursion method can still improve code reliability and structures. So we can see in this image how the rail recursion program was. So in this n into result, if again we take for loop n is equals to 0, return results. So return factorial n minus 1 n into result. So factorial in into n returns factorial n comma 1. So conclusion: recursion is a powerful tool in Java that allows from elegant solution to complex problems. It is important to careful design basics and uh, recursive case to avoid common fails. So understanding recursion depthly enhancing problem solving skills and prepares prepares you for advanced programming challenges. This presentation provides a overview of recursion method in Java, covering fundamental concepts, advantages and best practices. Thank you so much.